So we're gonna get started. This is David Yun, from MIT, and he's talking today about a bunch of work he's been doing at MIT involving extraction, computer interaction, faceted search, and I guess I'll let him kind of give a better introduction to that. So.
Thank you, Andrew. Hi, everyone. I'm very excited to be here today to talk to you. I'm constantly amazed at the ideas that keep coming out of Google, and in the past, I have borrowed one or two good ideas from you. So, after looking at Google Maps, it's kind of obvious that somebody should do a timeline widget. And I happen to be the first one, so here's my little timeline widget. And a lot of people have used it to do timeline mashups. So back here, you can see that this is a website that shows earthquakes. And at the top is the timeline showing when the earthquakes happen, and at the bottom actually the location on the moon. So talking about mashups, do you remember the first few mashups that came out? The more popular ones were housingmaps.com that took data from Craigslist and then put it on Google Maps. And then there's chicagocrime.org, which now has been part of every blog. So I was really excited about this mashup, so I told my friends about it and explaining to them how ingenious this was, right? So you scrape the data out of the web page, in this case from Craigslist, and then they put the data into a database, and then they serve it off on Google Maps. And the same thing happens with chicagocrime.org. So my friends say, "Wow, this is so great! I'm moving to Chicago now. I want to rent apartments that are far away from crimes. Can I put the two maps together?" And it's kind of very apparent right away that you can't do that, right? Without access to the database behind the website, you're on user land over here, and that's server land, and you can't reach across, get that data to do the mashup yourself. So if my friends were actually moving to Chicago, well, he needs to know more than just where apartments are and where the crimes are. He probably wants to find where the transportation, the subway stations are, where the schools for his kids, where they shop for his apartments, and so on. Now, he would have to wait for some, VC-backed mashup site to offer him all this data, right? And, the more unique the combination of his needs is, the less likely that there will be some site that does this for him. And, there's also data that he might not want to share with any mashup site. Maybe he's doing his budget for his move, and he doesn't want his bank account information to be put into that mashup. Or maybe he has some local data where his friends and relatives live in the city, and maybe he doesn't want that to be shared with the mashup. So this is called the server-side mashup paradigm, where the mashup actually happens on the server land instead of the user land. An alternative would be to swap that and do the mashup on the client side. And in order to do that, well, you gotta get all the data from those websites over. And then once it's over here, the user can use whatever tools that they have at their disposal to deal with that data. Maybe they generate a map, or maybe they actually want to use a spreadsheet interface to calculate the budgets or whatever. So my research goals for the last 3.5 years have been pretty simple. Just to get the data from server land over to user land, and then let the user do something useful with it. That breaks down into 3 topics that serves as my talks outlined here: data extraction, data publishing, and data integration. So actually, this message of getting the data to flow has always been one of the messages of the semantic web community, and that's sort of how it got started for me. So in 2004, in late 2004, I was really intrigued by the vision of the semantic web. And so I went to some people in the W3C, and I asked them, so, show me some tools that help people to get some value out of the semantic web data that they encounter on the web. And the answer is that there's no such tool. That's kind of a surprise, since, the first thing that Tim Berners-Lee did in trying to launch the web is to get a web browser built, so that people can actually look at web pages and see, well, this is useful to me. So since there's no tool, I started my research by building a tool called Piggy Bank. It's a web browser extension for Firefox that let people collect this data. That's kind of like bookmarking, but instead of bookmarking the whole page, you bookmark little tidbits of information on the page while retaining the structure of those tidbits. So if the web page you're looking at has a link to some RDF data, some semantic web data, then the extension would be able to scrape out that data and show you those tidbits over on the sidebar here. And then there's this little details button over here that when you click it, it would flip the whole content view of the web page and shows you that data in more details. Let's zoom in. For each of the record that it's extracted, there's a save button so that you can save that locally. So you can accumulate more and more of the data, semantic web data that you encounter on the web. And then you can later on browse through all of the data that you have collected. So that's why the name Piggy Bank, kind of collecting all that information. This is good and all, but then in late 2004 we looked around and there wasn't that much semantic web data on the web anyway. So the next thing we try is to support screen scraping to convert HTML into data. So we built the version 2 of Piggy Bank, and given a website like this website is showing movie shows, where they're shown, and the time of each of the show. So if you're looking at this website, there's a button down here in the status bar of the browser. You can click it, and it would run a screen scraper code on that page, and then shows you the data that it has extracted out in this view. So the result over here, and then on the right side are several browsing controls that you can use to narrow the results down to just the items that you want to save, and then save them. So these are filters, or we call them facets. So for example, if I click on PG, I would get the 16 GG rated movie shows. And then if there's any address information on that, you can just flip over to the map view and you plot that on the map. So this is user mashup. And you can scrape data from multiple websites and put them together on the same map. So I can show restaurants and movie shows on the same map so I can plan the evening. That's the usual scenario, right? So Piggy Bank is about screen scraping plus a very flexible data store that can hold whatever data that those screen scrapers generate. And this is where semantic web technology is starting to get useful. Traditional schema-centric database can't do that because for a conventional database, you have to design the schema up front, right? And you can't change it on the fly. So we have to use something called a triple store. And then in addition to that flexible data store, we also need to support generic browsing on top of that data. And we don't know ahead of time what that data is going to look like. We published our work to the International Semantic Web Conference in fall 2005, and the pitch was experience the semantic web inside your web browser now. And it's pretty well received. I think it's the first application to demonstrate client-side user-controlled data mashups. So the insight that we wanted to get across to the semantic web community was to show the usefulness of the semantic web technologies as early as possible, and that's actually possible, and that they have to work both with the user interface and the data together rather than just focusing primarily on the data. Now there's a problem with Piggy Bank is that, like Grease Monkey user scripts, the screen scrapers are very hard to write. They are in JavaScript, so you have to know JavaScript, you have to know how to walk through the DOMs and so on. And they are hard even for us. So the next thing we tried was to do automatic screen scraping. Now I know there's a lot of work with automatic screen scraping here, and I think you would agree that the three general challenges would be to first to locate the items of interest on the web page, and locate the fields within each item, and then finally label the fields. So you would say this is a publishing date of a book, this is the author's name, and so on. Now the labeling of the field seem to be the most difficult part for a computer. And let's take a quick look at why that is. So these are some search results from Amazon. And I think you would guess that they are about books. And then you would know right away that March 2nd is most probably the publishing date of a book. But that date is actually closer to the author's name. So maybe it's the author's birthday. Who knows, right? And there's nothing on the web page that actually say publishing date or publication date or published date or whatever. So it's very hard for the computer to be able to label that field. Let's take a look at another example here. So at the top we have two numbers, and I think we can guess that the first number is the original price and the second one is the sale price. And of course there's nothing on the web page that actually say that. But there's some visual cues and contextual information that we all know that make it super easy for us humans to know what those numbers mean. So since labeling the fields are very difficult for the computer, but it's easy for humans, so a lot of applications require the human to do the labeling. And in case that you actually need the field labels, that's fine. The user can understand the needs for those field labels and go through that chores. But in some applications, the need for labeling the fields might not be apparent to the user right away. So if you require the user to do all of that overhead work in front, they might not get through it, and then you might not get the result, the value out of the script process. So we're going to cheat. Well, we're going to not label the fields at all. And what we're going to do is actually let the people interact directly with the information on the page. So if they want to sort by the publishing date, the computer doesn't have to understand that's a publishing date. The human can just point at that and say, computer, sort by that field, whatever it is. So what you see is what you manipulate, in a sense. And in order to do that, we have to extract out the presentation, basically the HTML fragments from the page, and preserve them and let the user interact with that. So I built a web browser extension called Sifter that basically does that. It extracts out the HTML fragments from the page, and then on top of that, add filtering and sorting features onto the original web page as if the web page itself implemented those features. And all of that is done without burdening the user with labeling the fields first. So let me show you a screencast of that. So here we are doing a search on Amazon. We got a bunch of results. There are 3 pages. And then there's a lot of structured data within that web page. On the right side is the Sifter pane, and there's a single button on it. Let's say filter or sort items. And when you click it, it tries to detect the items of interest on the web page and then highlights them. So you can verify that it has done that correctly. It also indicates that it has found 3 pages. And then all you need to do next is click continue. Of course, if it doesn't do it well, then you can go back and correct it. So it goes ahead and fetch the 2 extra pages and then extract all of the data and then shows you the web page as if it were before the extraction happened. So everything looked the same so far, right? With a little exception. So in the web page, next to each of the field value, you notice that this little asterisk. They're basically direct manipulation handles so that you can grab on and do something with that field. So here, when you click on the asterisk next to the hardcover, you get a browsing control box on the right that you can use to filter the items on the web page by that field. So I click on audio cassette and I get only 2 audio cassette items. So what it's doing is actually rewiring the web page on the fly, taking out the original item HTML fragments and then do the query, see which one fits, and then put that back into the DOM. And then it also understands the date field, so it groups it into months and years. So we published that at WIS 2006, and the insights are that these human design presentations that you see on the web pages, they carry implicit semantics in their visual information. And then all you need to do is add this direct manipulation handles and then you can offer extra value on top of that data without ever requiring the user to do the labeling of the fields. And these presentations, when you scrape them and then use them again after you scrape them, it helps preserve the visual context so that the user isn't thrown into a totally different user interface and get confused. Also, these presentations that you see on web pages were designed by humans, so they generally beat any machine-generated presentations. They are visually appealing and concise within the context. So if you're searching for a book on Amazon, well, that's probably one of the best ways to show the information about books.
Are you merging multiple of these scrapings together into a single thing? So if somebody asks a similar query multiple times, are you going to use the labelings that you used in a previous one in the, if you hit Amazon twice, are you going to keep that information?
We haven't got to that part yet, but yeah, that would be a good idea to do. I'll revisit that topic later in the talk. So Sifter works, but it mostly works for the Web 1.5. Well, what do I mean by Web 1.5? It's the web where the content is generated from templates on server, ASP, PHP, whatever. It doesn't work for handwritten HTML, Web 1.0, and it doesn't work for Web 2.0. That's too dynamics. Now we are moving toward a Web 2.5, and the numbers become meaningless here, but just bear with it. So on Web 2.5, the websites start offering APIs for you to access the data. So Google Data API, there's Facebook API, lots of APIs coming out, but they are all intended for programmers. So the users still have the short end of the stick. And these APIs are all different, so it's kind of hard to build, a single application that works with all of them. I know there's some effort in unifying the APIs, but it's still coming, right? Now in Web 3.0, hopefully there will be a unified way for the user to actually get at the data, to access the data. And this is moving toward the semantic webs. So if we look at the infamous long tail, at the head of the curves are the types of information that are very popular or that are present in large quantities. They are, products, events, news, photos, movies, whatever you name it, all the common ones. And then toward the tails are very exotic, esoteric collections of data that people, hobbyists are interested in. Maybe you're interested in Lego sets, something like that. You collect a bunch of these, and you got a collection, and you want to publish about it, so that your friends who are also interested in would see. I think that there's a trend that as you move further and further along into the tail, you start encountering earlier and earlier web technologies. It's simply because that at the head of the curve, there's a lot of information, a lot of people are interested in these types of data. So then there's more money, more financial resources to build better websites, more modern websites. And then when you move into the tail, fewer people are interested in them. So, there's hardly a business model for supporting website with those types of information. Now, your mission that you have accepted was to organize the world's information, right? So you want to extract out data from the whole curve. And it's kind of easy to do it for the head. They already have all of the data in databases. As long as you show them some benefits of exposing some of that data, maybe they get along. And Yahoo Search Monkey is sort of trying to get at that. In the tail, it's kind of harder because these people actually don't have both money or programming skills to be able to publish the data in machine accessible ways. So the tail is hard to scrape, but you should scrape because you want to build an inclusive data web. You want on this Web 3.0 or whatever to represent both information that a lot of people are interested about and also more esoteric kind of data. And we know that the tail is actually, when you accumulate the information in the tail, it can rival the amount of information in the head, right? So that's a hard problem, but at the same time, the authors in the tail actually have a need to publish their data. They want to show their friends their collection of Lego sets. And they want to do it in modern ways, not in handwritten HTML ways. So can we kill those two birds with the same stone? So my approach to that is to build a structured data publishing framework called Exhibit that basically let these people with just passing knowledge of HTML be able to publish their data in rich user interfaces for the price of making their structured data easily accessible. So let me quickly demo that. Oops. So pretend you are a history teacher in a high school who wants to teach your students about the US presidents, and you have 42 presidents to tell them about. Let's say that you want to show them that most presidents were born on the east side of the country. So then you want to map the presidents by their birthplace. Maybe you want to show them when each president came into office, so you want a timeline here. You want to synchronize the two views. Maybe you also want to implement search functionality so that your student can quickly find Kennedy. Maybe you want to show the distribution of the presidents by their religion. So here it is. So you can see the number in front of the counts of presidents of that religion. And actually clicking on the choices in that list would filter the map and the timeline to presidents of that religions. And then you can also combine these various filters together, so I can filter that down by political parties as well. Now, in order to build such a web page using conventional technologies, well, what you have to start with installing a database, designing a schema, loading the database with a schema, and then designing your 3-tier web applications with the server-side scripts and the client-side script and connect them, and then trying to make them work together on all the browsers out there, right? So that's a little bit hard. But by using the exhibit framework that I'm going to show you, it's actually pretty easy. All you need to do is provide two files. One is the data file, and one is the HTML file. So let's take a look at the source code of this web page here. So at the top, there are two links to the data, and that's the data files are in JSON format, and I'll show you in a bit. And then there are references to the exhibit API here, and then there's also reference to the timeline extension and the map extension. And then down here in the body of the HTML, what you see is actually pretty much regular HTML except for extra attributes here that specify how this bigger widgets should be configured. So let me give you an example. So for that timeline at the top, this is what you need to configure. You say that here in the place of this div, render the timeline. So the view class is the timeline. For each event on the timeline, retrieve the in-date property of the records, and then use that as the starting date of the event. So these are little expressions here that would bind the database to the view, right? And then the same thing goes with the maps here. And in order to show the president's portraits in each of the icon, all you need to do is say x:(icon) equal .image URL. So using this very declarative means, the user can quickly build that interactive web pages, which is basically passing knowledge of HTML. And if the user happened to look at one of these web pages done by someone else, they can look at the source code and then just copy and paste, just like how HTML was usually authored originally, right? You copy somebody else's code. Now this is the data file, and it's just JSON, and it's basically a list of records, and each of the record has property value. So it's pretty simple. This is another example that we have. It's exhibits of mushrooms, and you can filter the mushrooms by the cap shape, by how edible it is, and so on. So just to show you the breadth of the kind of widgets that we support. So what have people done with exhibits since we released it? Well, there's quite a variety of types of data that people have published. So here is test operations done in the James Watt Telescope, collected by somebody at NASA. And basically, he just wanted to plot those events on a timeline, and also be able to filter the events by, I guess, some sort of classifications by the I don't know this data that well, but you can get an idea of how he wants to interact with the data. And maybe it's not useful just for himself, maybe for his colleagues as well. This is 305 ongoing projects at the Pakistan Development Portal. You can filter these projects by the country that financed the project, by the sector that the project's in. So lots of structured data here. And oh, by the way, when you look at an exhibit like this, there's this little scissor that you can click and get the data out in various formats. Well, actually, if you look at the source code, you already see the data at the top here. So there's actually no scraping. You just grab the data. This is, I believe, a class project that tried to plot the contamination level at various cities in Spain. A music composer database done by someone with very little knowledge of HTML. This is an example of exhibit integrated into a news website, and it's pretty well integrated that you can hardly see that it's exhibit, except when you actually click on any of these filters and then it starts to behave like exhibit. This is a scandal for those double dippers. This exhibit is done by the Mozilla Firefox team while they were completing Firefox 3. They want to track their design documents, and so they want to filter by the priority of each design document, whether it's at risk, and so on and so forth. What's interesting about this one is that when you view the source code, the data is actually coming from a Google spreadsheet feed, and we support this natively. So you can collaborate, editing the data in your Google spreadsheets, and then just view the data somewhere, on an exhibit. This is clinical trial events with data on people, I guess the patients, the drugs, the adverse events, and so on. This is somebody's ancestral timeline, where people of various lineage in his family, when they were born and where they were born and where they die, and so on. This is exhibit showing 56 pictures of collections of rocks. So I'm telling you, we are getting further and further into the long tail here. This is the gesture project, so you can learn how to these various kinds of gestures. So this is how to do "duh" in Colombia. I don't know whether it plays, but anyway, now you know. So the features for Exhibit is that you don't have to deal with database, you don't have to install, set it up, do schema design, you don't have to design this 3-tier web application. What you get are rich views, maps, timelines. I forgot to show you the scatter plots and whatever else, right? And you get advanced faceted browsing, filtering, search with very little work. How do you use it? You just provide data in the files or in a Google spreadsheet feeds or any other kinds of feeds, and you use an extended version of HTML to configure these big widgets and how they're linked together. This is done all in JavaScript. It's basically a 3-tier web application framework in JavaScript. And the presentation template, oh, I forgot to show you that. So back here, when you click on a precedence, you see this nicely formatted rendering. That basically is done by specifying what's called a lens template. So normally you would do this on the server side in JSP, ASP, whatever. Now we just do it on the client side. It's pretty simple. So just want to show you that it does run on handheld device, Nokia N800, on the little Royal PC. And then we also have a version on the iPhone. Well, this is not running on the iPhone, but just to get you an idea. So why that's good? Basically, you have the same data file, either it's a data file or data feeds, and then you can create different HTML files for different devices. It's good for ad hoc mobile data browsing apps. Let's say you have a little conference with 100 events. Maybe you want people to be able to carry the schedules on their iPhones or something. It would be trivial to generate one of these. So Exhibit is about letting people publish data. I want to take a minute to relate that to the semantic web community's vision. So for a long time, the semantic web community has been telling people to publish data so that someday someone might get some random use out of the data that you publish, and we have a better world. It's very hard to motivate people that way. People tend to optimize for short-term personal benefits over long-term prospect to someone else. So with Exhibit, there's a clear purpose to why you publish the data. Well, you want to share that data with your friends. It's the same motivation for you to publish a web page as to use Exhibits, right? So it's the human-to-human communication that's the end, and the data is just a means for that. And this actually helps drive the design of the presentation and also the design of the data. So let's say that you want to show your students that most presidents were born on the east side of the country. Well, the best way to show that is to plot them on a map. To do that, you need the latitude and longitude of the data. So then you go about and enter all of that, and then you get the result. This is different from semantic web vision because for the semantic web vision, if you publish data without an audience, how do you know what data to include? How much data to include, and how do you verify the quality of the data? Because there's no purpose. It's like giving a talk without knowing who you're talking to. So if data is just a means to an end, then we can try to ease the pains of handling data as much as possible to get people to reach their goal. We do that by avoiding the need to design the schema and to design the schema. So if you look at the data file of the exhibits that I've shown you, let's go back for a second here. You can see that there's pretty much no schema. You just start typing in data, and the database in Exhibit would just take it. Of course, you can add more data, and that would make your exhibits look or behave better. So if I go to the schema file here, you can add things like for things of type precedence, when there are many of them, add an S to the end. You can add more schema to make things look nicer, but you don't have to. So you can start out the easy way and then iterate until you get to what you want. So we published exhibit to the World Wide Web conference in spring 2007. And so far we have released version 2. The code is on Google Code. We got a lot of adoption in the government agencies, in the non-profit organizations, in news agencies, even in the industry like Mozilla that I've shown you. There's a lot of experimentation with exhibits by the scientists in research labs. What they want to do is for scientists to be able to quickly generate this visualization of experiment data without the need to call on programmers. And then conferences are using exhibit to show their schedules and events. Even developers are using it. Drupal is trying to, or the Drupal developers are trying to see whether exhibit is good for the front end of their web applications. But most importantly, individual people are using exhibit. So the activists, hobbyists, historians, teachers, students, and so on. That scenario that I show you about using Google Spreadsheets as the back end of exhibits, that's really popular for teachers to let the students collaborate on entering the data. So we have about 1.5 years of server logs. So every time somebody uses exhibit, they include the exhibit API.js, and our server gets a referral URL. So we got around 800,000 servings of the API, and we distilled that down to around 16,000 unique referrals. 6,000 are HTTP retrievable. The other ones are inside intranets or local files. Actually, a lot of people are using exhibit internally in intranets, and they want to know how to download the code. So they 3,500 referrals are indexed by Google or Yahoo, so we consider them to be public. Those exhibits have been linked off from some other web pages, so the authors actually intended them to be visible to the world and not accidentally visible to the world. So we crawled those, and we got out 2,800 that contains data. And of course, there's a lot of duplicates, and then since I'm not so good with crawling, so I need to resolve the URLs and so on. But with all of that data, I put all of the data together into a single store, and I call that the exhibition. Basically, I'm trying to do a search engine on top of all of these public exhibits. So here's a very, very early prototype of that. You can see that the data, the structure of the data is all retained. And over here is a filter by type. And you can start to see that this is getting into the long tail. So there's like 2,000 dams. There's authors, trajectory, I guess that's, I don't know what that's about. Counties, dogs. There's an exhibit on dogs for adoption. This person want to keep track of her dogs. There's treatments, Cliff Book, mutant genes, add-ons, destroyer. So a lot of very esoteric types. Anyway, there's still a lot of work to be done in this area, such as supporting text search, supporting faceted browsing on this heterogeneous collection. Now we got all of that structured data, but we don't know what the experience would be like to do faceted browsing on that, because all the fields are different. Right? You're getting into the long tail, you get all sort of things in there. We want to support map views and timeline views automatically. And we know that because we can see how these views are configured in the HTML of the exhibits. So it's easy just to grab those expressions out. And we also want to scrape the original lens templates that is now very visible in the HTML code. And we also want to extract the CSS rules. And with those two, we can then render each of the search results as if how they appear in the original exhibits. Because we want to automate this scraping process monthly. There's also questions to be asked about how it's actually being used, like how long tail is the data, how large is the community and number of visitors around each exhibit. Is it just for one person? Is the person using exhibit just to browse through his own data, or is he sharing it with his friends? We want to track the copy and paste behavior. We want to see whether one exhibit looks kind of like another with just some changes. And we want to know whether authors are capable of, well, whether they can configure the filters and the views in their exhibits wisely to best show their data. And of course, we want to convince certain search engines to index these exhibits. So, future work-wise, right now, in order to author an exhibit, you need to edit the HTML code by hand. Now, HTML is good to get, the original early adopters of the web started, but it's not until block engines that get on board. So we also want to provide WYSIWYG authoring for exhibits, and that shouldn't be too hard because the way you configure exhibit is by this declarative syntax. So that's easy to provide WYSIWYG tools for drag and dropping these widgets. We're actually working on something like that. We have talked to some people at Adobe, and maybe they would be interested in putting it in Dreamweaver. Now, one thing about exhibit is that right now it's implemented in JavaScript, so it doesn't scale beyond a few hundred items. But JavaScript engines are getting faster, and browsers getting faster and all that, so it's not too bad. It's already useful as is. But we do want to explore one possible solution for scaling up exhibit. So right now, when you're looking at an exhibit, what happens is that the browser loads the HTML, usual. It sees that there's a script link to the exhibit API, loads that, and that kind of unfolds itself into a web application framework. And that goes back and read the DOM and see that there's a link to the data file, and then load the data file into a database. So in order to scale this up, we want to move the database over to the server side. And then we have to split the code so that some of the code would sit closer to the database. We started to do this work, and we called the combination of those two components Backstage. So how do you use Backstage? It would be the same as an exhibit. So you would provide a data file or data feed, and then use extended HTML for configuring that. And then you set a flag to supersize your exhibit, and it would just basically render you a web app on the fly. Tell the web app where the data is. The web app would just load that data file into a database on the fly, and then serve the UI to JSON-P. Now, actually, you don't have to run a web app. The user computer is powerful enough to do all of this calculation anyway. So then it would be interesting if we can get something like Backstage to be shipped with the browser. Right? So the browser would put the data and the presentation together in the last minute. So instead of the web app on a web server serving HTML, you would basically feed the browser HTML and the data file. And then the browser itself has something like Backstage or Exhibit, and then it would just construct the application on the client side. So we would be dealing with more than just the document object model. We would also be dealing with the data model. As for the HTML configuration part, right now you need to include Exhibit API at the top, and then you use this div. You overload the div to configure the big widgets. But a better way to do that would be to use our own kind of elements. Exhibit view and exhibit facet, for instance, in a future version of HTML, and then you don't have to include exhibit API anymore. So hopefully, if we get a lot of traction, then all of the Web 1.0 web pages in the tail start to turn into Web 3.0 because the data is so easily accessible. And a lot of web pages that never get published because it's hard to publish, right, might actually get published, so they got onto the web. Now, the next problem is that you have a lot of these exhibits with different schemas. What do you do with all of that? Can you integrate the data from several exhibits together? Well, so that's the second problem that I'm trying to address. In addition to get the data to the user, well, we've got to connect the data together. And my solution would be to connect the data one usage scenario at a time. So when the user encounters two different exhibits that they want to integrate together, they can do that at that time, rather than trying to go for some sort of global data integration. So this is do-it-yourself data integration, personal data mashups. Now there's been a lot of research on data integration tools in the database community, in the semantic web community, and a lot of them focus on large data sets with hundreds of classes, hundreds of properties, and so on. So they need very specialized tools for experts to be able to do the data integration, and this usually scales to users. So you have to know things like some sort of class hierarchy, that a person is an agent, is a thing. That might not make sense to a normal user. So I believe that a lot of data sets that you encounter on the web tend to be simple enough that you can handle with just direct manipulation in order to integrate them. So I built a tool called Potluck that starts to explore how to use direct manipulation for personal data integration. So let me demo that. So here's the scenario. These are two exhibits about people. This one is about the principal investigators at MIT CSAIL lab, and it's built with exhibit. And there's a lot of data like people's position, where their offices are. And this is another exhibit about people in the Columbia University Center New Media Teaching and Learning. And let's say that there's some sort of collaboration between these two labs, and our task is to create a single directory of people's contact information. So here's a tool called Potluck that can do that. And what you need to do to use it is to copy and paste the URL of these exhibits over here, and then click Mix Data. So it goes and it grabs those data files of the exhibits and kind of put them together, show you in a somewhat raw data form here. And the properties are color-coded by their origins, where they came from. So the blue ones came from the MIT CSAIL website, and the pink one here come from the Columbia website. And I can start right away with constructing a table of people's contact information, and let's say I start with their position. So I can drag position here over job position. Now that works with the first record, but it doesn't work with the second one, because the second one comes from the other data source, and there they call it title instead of position. So I can just drag that in, and that merged the two fields. So this is somewhat different from conventional data integration in that in the conventional data integration, you integrate the data, finish all that, and then do the visualization or whatever you do with that integrated data. Here we are going to be building the visualization and integrating the data on the fly together, iterating until we get what we want. So I can actually undo this, and now the two fields are separate, and I can redo it, and the two fields are together. So let's put people's phone number into a column. Now you notice that for the CSAIL people, they don't have area code, but they are all in Boston, so we know their area code is 617. So I'm going to enter their area code for 92 of them. So I'm going to click this edit button here, And what that does is it clusters the phone numbers into columns based on similarity. So everything in the first column starts with 253. In the second column, 212. And then the third column is everything else. Anyway, I'm not so good at machine learning, but you get the idea. And then this makes it easy to see the outliers. So here's somebody's extension without the full phone numbers. Now in each of the column, you get several cursors, a text cursor. So my cursor is on the first row here, but you can see in the other rows there are these fake cursors. When I'm moving the primary cursors, the other one moves with it. And basically, you can use this to edit all the rows in the same column at the same time. And then you can get picky with this, for instance. Okay, I'm not going to do it for the other ones, but you get the idea. Now, this is useful for extracting out subfields within a field as well. So if you look at the office field, there's actually a building number and the room number here. So what we want to do, let's say, is to extract out the building number. So what we can do is drag this over and make a copy of that field, and then use the simultaneous editing features to delete the room number and then typing in building in front. And then save. You can also use drag and drop to create filters. So I can drag this over here to make a filter, and then I can click on that to get only 3 people who work in building 46. And we also have a map view where you can drag addresses onto this targets to plot records on the map. But I don't have time to show you that. So it would be interesting if we can integrate Potluck with something like Sifter. Notice that Sifter already have these handles where you can click on to interact with that field. Now you can do data integration from several websites by dragging those little asterisks together into the same column or into the same filter. So I think that's sort of getting to your question. Now, if enough people actually taking the same data integration action, let's say merging together position and title, maybe that would give a heuristic for the computer to infer that these two fields are equivalent. But maybe it's not. Maybe they just want to see this in the same column. But that's sort of how I'm seeing this approach getting to the problem of addressing the millions of schemas out there. So hopefully, like taxonomies where people just tag for their own purpose, but then you get these taxonomies arising from their tagging actions. Hopefully we can get toward a unified schema by people doing data integration one scenario at a time. So to wrap up, I want to go over the list of things I've shown you. In the data extraction topic, we have Piggy Bank, which is a scraping tool that has a flexible data store to store whatever kind of data that the screen scrapers produce. And then we also have a generic browsing UI that lets you filter and browse to these results that you have collected, plot them on the maps, and so on. It's the first one that demonstrates client-side user-controlled data mashups. Then we have Sifter, which is a tool that does automatic screen scraping by extracting out the presentation rather than labeling the fields. And then it adds in this direct manipulation handles next to each of the field value so that the user can grab on and directly manipulate the fields. In the data publishing, on the data publishing topic, I show you an exhibit, which is a framework that lets people publish rich interactive web pages with just passing knowledge of HTML for the price of making their data easily accessible. So this is hopefully able to capture the data sets in the long tail of the web. I've cropped a lot of those exhibits and put them together, and hopefully building a search engines on top of all of these public exhibits. I also talk about Backstage, which is an early prototype of how to scale up exhibit. The concept there is that you can run a web app on the fly to do all of the computations, and all you need to do is provide the data file and the HTML configuration. And finally, I show you Potluck, a do-it-yourself mashup tool that's probably good enough for simple data sets that you encounter on the web. And it uses direct manipulation techniques like drag and drop and simultaneous editing to let the user do the data integration while constructing the final visualizations. This work was done over the last 3.5 years in 3 research groups: the Haystack group, the user interface design group, and the Simile project. And for more information, you can visit this website. And some questions.
For Sifter, did you have difficulty with deliberately broken HTML?
I think it doesn't have to be deliberate.
For instance, Yahoo, when I was doing stuff years ago, Yahoo deliberately breaks their HTML in a number of ways, and it breaks it differently each time in several different ways. There are some companies that will make your data easily available. Some try to make it almost impossible, try to make it as hard as possible to scrape. I was wondering how much of that was an issue in your Sifter work. I
actually was not noticing that. I think I actually had enough trouble trying to make it work on regular website. I didn't notice the aspect of them trying to break But in some of the cases, so in Sifter we try to detect next page's links. Like if in the search result you have several pages. There's a lot of trouble in that, since the website can try to append irrelevant parameters, and it confuses.
So aside from the scalability issue, the other main limitation of this that I see is that most of the data is basically static. And so if you want to build an application where people are editing the data on the fly, shared across users, then you need a different way to store the backend stuff. And I guess Backstage also maybe could start to get towards that type of thing, but have you done any work towards that?
Yeah, so another approach is Google spreadsheets, where the feeds would get updated every 5 minutes or something like that. So we have heard our own users asking for that. There's a student who started working on that right now, but nothing to show yet.
How do you detect next pages?
So we can, there are a few heuristics. One is to look at all the links with the numbers, right? Page 1, 2, 3, and so on. The label of the links. Or you can parse out the parameters in the URLs of those links and see if there's a sequence. If that doesn't work, then you can let the user click on the next page link. So it's a compromise between,
So we started out talking about the semantic web, and very graciously said all the ways that it didn't work.
Are we almost done?
Yeah. You're talking to David anyway, so you want to
Yes.
Thank you, David.
Thank you.